Today I will start a new lecture series on electronics. This lecture is suitable for B.sc B.Tech M.sc NET and competitive exam like DRDO, ISRO, etc. So, in this lecture, I will discuss the energy band. What is the energy band? Okay. So, it is a fundamental topic on electronic devices and circuits. Okay, electronic devices and circuits. This unit has a sub-unit, the transport phenomena in semiconductor. When we will study the transport phenomena in semiconductor, that is the important topic is energy band. Okay, so today I will discuss on energy band. In this lecture, I will discuss on formation of energy band. Number 1, formation of energy band. Number 2, why the inner band is narrow and outer band is wider. Number 3 is what is the band gap, and number 4, the conduction band and valence band. And most important, why the electrons of inner band does not take part in the process in forming energy exchange. And here you see that the 6 which electron may receive the energy from external source. Here the main fundamental question. If you know this fundamental topic on energy band, then you will be able to answer any type of question. Okay, so let's start the formation of energy band. The formation of energy band. To know the process or formation of energy band, you have to know the electronics, that means atomic structure. Okay, so according to atomic structure, every atom has a nucleus. Okay, nucleus, and around this nucleus electrons are moving with some specific energy level. Okay, and there is a number 1 is n. N is called principal quantum number. Okay, number. And L is angular momentum quantum number. Momentum quantum number. And M is magnetic quantum number. So this is 3 quantum number. Okay, using these 3 quantum number, we can discuss the position or configuration of an electrons in atom. Okay, now you know, according to atomic structure, you know that electrons in an isolated atom, this is very important, isolated atom have some certain energy level. Okay, this is certain energy level. Like 1s, this is a 1s is a energy level. 2s is a energy level. Okay, 2p also energy level. 3s is also energy level, and 3p also a energy level. So according to atomic structure, electron in an isolated atom has some energy level like this. Okay, this is a one energy level, and each energy level have several quantum number. Several quantum number. Okay, several quantum number. Now you have to know that the process, the process of electron configuration. That means how the electron distribute through this energy level, how the electrons are distributed through these energy levels. Okay, to know this configuration, you have to know one principle, that's called the Pauli exclusion principle. Pauli exclusion principle. Now, what is Pauli exclusion principle? Pauli exclusion principle actually determine the maximum number of electrons can be accommodated by each energy level. Okay, energy level. So Pauli exclusion principle actually determine the maximum number of electrons that can be accommodated by each energy level. Okay. Now, what is the principle? Pauli exclusion principle says that the maximum electrons. That means if I say the exact principle, then I will say that the Pauli exclusion principle is that the no quantum states can contain no quantum state can contain more than one electrons. Okay, one electrons. So here the Pauli exclusion principle says that each quantum states can contain only maximum one electrons. Okay, maximum one electron. That means one quantum states can contain only one electron. Suppose here is the quantum energy level. This is the energy level. Okay, suppose there is a 1s energy level. This 1s energy level has two quantum states. That's why it contains two electrons. Suppose this is a 2s. This is the energy level. Okay, this energy level has two quantum states. That's why it contains two electrons. If I say 2p, it has 6 quantum states. That's why it contains 6 electrons. Okay, this is the process how the electrons are filled in the various energy level. Okay, this is the process. If I take sodium atom, it has 11 atomic structure, atomic number. Okay, that means it has 311 electrons. If I say that the electronic configuration of the sodium atom, then it will be 1s2, 2s2 and 2p6, that will be 10, and 3s1, and the next 3p is vacant. This is vacant. So the electronic configuration of sodium atom, you have here you see that the 3 energy level, that means up to this, all are completely filled. Completely filled. But this 3s1, 3s, this energy level is incompletely filled. Incompletely filled. But this, the higher energy level of greater than 3s, this is completely vacant. Completely vacant. Okay, this is completely vacant. Now, if I brought together the n number of sodium atom far from each other, then what happens? That means here I have brought n number of sodium atom. This is a n number of sodium atom. Suppose this is a n number of sodium atom. Okay, these atoms are far from each other. Okay, then what will be happen? What happened? The energy level of this atom 1s, here is energy level 1s, here it has a energy level 1s. That means the energy level of 1s of each atom, each atom are identical. Okay, so 1s energy is identical for each atom. Similarly, the 2s, 2p and 3s, all the energy level are identical to each other. Okay, this is the, so if I take the, that means this is a 1s energy, this is a 2s energy, this is a 2p energy, and this is a, suppose 3s energy. This is the energy level of isolated atom if the sodium atom are placed far from each other. Now if I brought together the n number of sodium atoms close to each other, then what happens? That means there is a, it is a sodium atom, this is a sodium atom, this is a sodium atom, this is a sodium atom. In this way, there is a n number of sodium atom and these sodium atoms are close to each other. Okay, then what happens? Here you see that the uppermost energy level, the uppermost energy level is 3s. This is a 3s. It is a incompletely filled. So the uppermost energy level 3s will interact. Okay, interact with the neighboring 3s energy level of another atom, of an atom. Okay, that means here the uppermost energy level 3s are interacting with each other. That means here you see that the 3s energy level of each atom each atom, okay, will interact. Okay, for this interaction, there will be change in energy level 3s. That means a 3s energy level will be changed. So this change is not same. This change is not same for all atom. Okay, that means some is shifted. The energy 3s energy is some 3s energy level shifted up. That means suppose this is a 3s energy level. 3s actual 3s energy level. But due to this interaction, the change in 3s energy level, some will be shifted upward and some 3s energy level pushed down. Okay, down. That means another energy level is pushed down this. Okay. Now the magnitude of change. Now this change, that is the change. That means magnitude of change is not magnitude of change in 3s energy level is not identical. That means some is here is this, another is, suppose this is another change, this is another change, this is another change, and suppose there is another change, there is another change. Okay, all atoms have several magnitude in change. Okay, for this, here you see that this is a energy level which is for this region. You have seen that there is a closely spaced energy level. For this you have seen that there is a closely spaced energy level. Okay, first you have already know that this energy level is sharp. Here this 3s energy level is sharp. Okay, sharp energy level. But for the interaction, the energy level is not sharp. This is a closely spaced energy level. Okay, for this closely spaced energy level, create energy band. Okay, this is create energy band. This is the process. So this is a 3s energy band. So this is a 3s energy band. I hope all of you understand how the energy band is formed in metal, semiconductor, that means in materials. Okay, this is the first question I have completed, that means the formation of energy band. Here similarly, this is the 3s energy band. If I draw the energy band, then it will be like this. If 1s energy, this is a 1s. If I take in this way, this is the sodium. For sodium, energy band of sodium, energy band of sodium. And what will be happen? This is a, suppose this is a 1s energy band. Okay, and there is 2s energies level. Then it is 2p energy level, energies band, and here is 3s. This is, suppose this is 3s energy level. Okay, this is the 3s energy level. These are completely filled. Okay, so this is a 1s energy band, this is a 2s energy band, this is 2p energy band, this is 3s energy band. Here you see the difference between the two energy level. This is more thin, then this energy level is the wider. That means the in sense of width, that 3s is greater than 2p greater than 2s greater than 1s. In sense of width of a energy band, this energy band is more width, the wider than this, and this 2p energy band is more wider than 2s. The second question is that why the inner band is narrow and outer band is wider. This is the question number 2. Here you see that what is the question number 2. Here I will answer the question number 2. That means why the inner energy band is narrow and outer energy band is wider. Why? Okay, wider. Because this energy band has created for the interaction. That means energy band are created. This energy band is created for the interaction of energy level. This is most important. Interaction of energy level. Okay, energy level. If this interaction is more, that means the interaction is more, that means stronger, then the energy band will be wider. Okay, if this interaction is weak, then the energy band will be thinner. Okay, this is the condition, this is the explanation. That means here for sodium, the interaction of 3s energy level is stronger than the interaction of 2p energy level. Then the energy level of the interaction of 2p energy level is stronger than 2s, and in this way, that means the interaction of energy level in sense of interaction, this is the condition. That means the outermost energy level has stronger interaction to each other. That's why the outer energy band is wider, and the inner energy band is interaction is not stronger. This is the interaction is weak. That's why this energy band is thinner. This is the question number 2. I have explained this question. Okay, number 3, what is band gap, and number 4, conduction and valence band. Okay, conduction and valence band. Here, what is band gap? Band, number 3 question, band gap. Also here I will discuss the conduction band and valence band. Here I have, this is the 3s energy level for sodium, this is a 2p, okay, this is a 2s and this is a 1s. These are completely filled. Here, what is the band gap in this condition? Okay, for sodium atom, what is the band gap? You have to understand. Here, the if I give this, it is a band gap. All of you know that this is a band gap. This is a band gap. This is not a band gap. This is not a band gap. And here, this is not a band gap. Okay, this is a band gap. That means this is the energy band. That means energy difference between these two energy band. Okay, how this difference is? That means the what is the band gap? If you want to tell the definition of band gap, that means the difference. That means the difference between the highest energy in energy band. Suppose this is a 2p energy level. The highest energy in energy band, this is the highest energy of 2p band. This is the highest energy, and this is the lowest energy of 2p band. This is a lowest energy. Okay, here the difference between the highest energy in energy band and the lowest energy of the next higher energy band. Okay, here is the next higher band is 3s. This is the lowest energy of 3s. E of 3s, this is lowest, and E of 3s is here is highest. Okay, that means the energy difference between the highest energy on energy band and the lowest energy of the next higher energy band. This is the band gap. This is not a band gap. This is not a band gap. And if I draw, this is not a band graph. This is a band graph. Okay. Now I have explained what is band gap. Now you have to know what is conduction band and valence band. Suppose this is a valence band. What is the valence band and conduction band? Valence band, the energy band which has completely filled. The energy bands which are completely filled, okay, completely filled is called valence band. Here for sodium, it is this is a valence band, this is a valence band. For sodium, this is a valence band. This 2s is not completely filled. That's why 2s is not a valence band for sodium. Okay, for sodium 2p is valence band. Okay, this is a valence bond. Where if you take an atom, which suppose another atom is, suppose this is, and this is another. This is completely filled, this is completely filled, and this is completely vacant. Suppose this is a completely vacant. If this is completely vacant, if this is completely filled, then it will be valence band, okay, for this configuration. But here for sodium this is not completely filled, that's why 2s is not valence band. Here for this 2p is valence band, here is 2p will be conduction band, okay. Now you have to understand what is conduction band. Conduction band, what is conduction band? The highest energy band is called conduction band. That means what is conduction band? Conduction band is the highest energy band is called conduction band. That means the bands which has highest energy, which is highest energy. For this sodium, this is the highest energy, 3s is highest energy. For this is a conduction band, okay. Now for atom which is completely filled, this is completely filled and this is completely vacant, that means the highest energy for this configuration is this band, so that's why this band will be conduction band, okay. This is the definition. That means I have completed that what will be the definition of conduction band, what will be the definition of valence band, and what is the main definition of band gap. Now the second question number 5. Here the why the electrons of inner band does not take part in the process involving energy exchange, okay. Why this not? Suppose that means question number 5. What is the question? Why the electrons of inner band do not take part in the process of energy exchange, okay, energy exchange. Why this? Here already I have discussed the energy band of sodium. This is energy band of sodium. This is 1s, this is 2s, this is 2p, and this is 3s, okay. Now according to Pauli exclusion principle, or according the Pauli exclusion principle, the electrons are accommodated by this energy level. First 1s energy will be filled, then 2s energy level will be filled, then 2p energy level will be filled, then 3s energy level will be filled. So in this way electrons are accommodated by this energy level, okay. Now at 0 Kelvin temperature, the energy of electrons is lowest. At 0 K temperature, the energy of an electron is the lowest, okay. Now you have to know what is the allowable energy exchangeable, what is the allowable exchangeable energy, or exchangeable energy. Exchangeable energy. What is the exchangeable energy? The exchangeable energy is in the order of kT. This is the order. K is Boltzmann constant. Okay, Boltzmann constant, and T is the temperature in Kelvin. Temperature in Kelvin scale. So if one electron wants to receive energy, then in the order of kT, in the order of kT, the energy, that means the minimum energy, experimental energy del E equals to kT. So in this order, one electron can receive energy or one electron can donate energy. Okay, this is the exchangeable energy in the order of kT. Now at room temperature. At room temperature, what is the room temperature? The room temperature is T equals to 27 degree. That means in Kelvin it will be 300 Kelvin. So if you put the value kT, this is 300, and the Boltzmann constant, then it will be 0.026 electron volt. So in this order, one electron can receive this energy or exchange this, can be exchange this energy. Okay, now you go to these states. If you take the 1s energy level, this energy level is completely filled. If you go to the 2s energy level, this is completely filled, and this 2p is completely filled. So for the 2s and 2p, for the 2s and 1s, for this there is no vacant space for electrons. So if the electron of 1s wants to receive this energy, but he cannot go on the higher energy level, because there is no vacant energy level around these 2s. Okay, that's why the electron of 1s and electron of 2s cannot receive this energy. Okay, cannot receive the external energy because there is no vacant space. So if this electron of 1s energy level wants to receive this energy, this electron can have to go the higher state, but there is no higher vacant space in higher states. That's why the electron of 1s and electron of 2s cannot receive energy from external source. Okay, do you understand? Now in case of 2p, there is a vacant space in 3s, and the electrons of 3s, there is a vacant space, like this is 3p, energy level. So for this 2p and 3s, electron of 2p and 3s can receive energy, okay, received energy, because there is vacant space. There is a vacant space to move the higher energy level. That's why the electron of 2p and 3s can receive the energy from external source. So here I will discuss this question: why the electrons of inner band do not take part in the process of energy exchange, but the outer most electron can take the energy from the external source. Now, what is the sixth question? Sixth question, that means which electron may receive energy from external source. So in question number 5, I have already discussed which electron is able to exchange or take energy from the external source. The outermost electron. Okay, the outermost electron, this is the outermost electron, can receive the energy from external source. So stay tuned with my channel. I will upload step by step all lecture related to electronics. Okay, this lecture is suitable for B.sc Electronics and B.Tech Electronics and Communication Technology. Okay, and NET also. I will discuss the next, the transport phenomena and electronics. Okay, thank you.